Hello everybody, this is Andy Pils and it's day 9 of our unit on climate. And in today's video, I'll be going through this high adventure science interactive titled, What is the Future of Earth's Climate? So in these activities, we're going to be taking a look at data and identifying some trends and patterns that we see in order to make inferences about what might happen to Earth's climate in the future. So we'll begin the activity. My recommendation for each of these sections would be to pause the video if you're following along with me and read the introductory information. That way you know what we're going to be looking at. I'll be covering the graphs and maps that are presented in this video, as well as the questions that follow each section. So in this TimeLabs video, we're going to see a color-coded map showing us the temperature anomalies, meaning how much the temperature was deviating away from the average. And the average here is going to be about like the mean temperature between 1950 and 1980. So if we were to look at this map and the trends, we're going to see that up to 1950, most of the map is blue, indicating that the temperature anomaly was a little bit cooler than average. We still see some warm spots, but again, they'll cool off again. So for the most part, up until 1950, the trend that we're seeing is mostly lower than average temperatures. And when we get to this time after 1950, so the 60s, still pretty cool, 70s, still pretty cool. And then right at 1980, we start to see some warm colors, meaning that in those areas, the average temperature is a little bit warmer than usual. But then look what happens within the past 40 years. So we're going to see a lot of yellow. Then we're going to start to see a lot of red coming onto the map. Orange and red indicating that those average temperatures are higher than average. So let's take a look at the questions that are here. So what do the colors indicate about the change in temperature over time between 1884 and 2019? Well, it looks like on average between 1884 and 1950, much earlier in that time span, the temperatures were cooler. But as we look at the more recent history, it seems like the temperatures were on average more than the average temperature. Question 2, in the past 50 years, where has the temperature changed the most? So if we were to look at past 50 years, so about 1970, we'll see some blue areas here over the Atlantic and Pacific Oceans, blue in northern Africa, a little bit of orange and yellow in northern Russia. But I think the biggest difference here, at least what I can see, between here and here, it appears that the biggest temperature difference is in this northern latitude here up by our ice caps, our polar ice caps. So that could be dangerous if the northern latitudes are experiencing greater temperatures than average, and not just greater than average, but up to 2 degrees warmer than the average, which will have a pretty significant impact. All right, so let's take a look at the next section, section 2. So in this graph, we're looking at global mean estimates based on land and ocean data. So this is going to show us the temperature change or the anomaly from 1880 and 2019 compared to that average that we were looking at between 1950 and 1980. So each point on the graph is the average of the last 12 months or the last 1 year, and the red line is going to be the average of the previous 5-year period. So these data points are the last year. The red line is going to show us more long-term trends as to what's happening. So question 3 asks to describe the average temperature change from 1880 to 2019. So don't be fooled. If we were to look right here in this middle, so about between 1950 and 1980, it's right around this 0, meaning that's about the average that we're looking at. And if we look at the times before that, it was mostly below. We do kind of see this one deviation here, but for the most part, with this 60-year span, the temperatures were lower than the average. And when we look after 1880, we're going to see that the temperatures are higher than average. So 0.5 higher than average and almost a degree higher than average lately. So not only in this time span, in this 40 years has it increased in temperature, but we're seeing it increase by an even greater amount. So in this span between like 1880, 1890, it is increasing, but only a little bit, only I would say about 0.25 degrees Celsius. But if we were to look at this 10-year span over here, it's increasing by more than a half a degree per year, so the amount that it's increasing is increasing. All right, let's go on to the next section. Okay, this next section is going to go over the different types of ways that we can look at data and work with it. So again, the black points are going to show the average, the anomaly from the past year. The red line is going to show the 5-year average. So that's kind of showing the long-term trends or the long-term changes that are occurring. Here's something new. The gray shading shows the scientists' uncertainty with the data. The gray areas show the range of temperatures that scientists think could be right for each point in time. Let's take a look at some of the questions. Okay, why is the curve between 1950 and 1980 relatively flat and centered around the 0 degrees difference from the baseline? Hint, how is the temperature change being compared over time? So remember, we're comparing this average from that span of time, from 1950 to 1980. So it kind of makes sense that this would be hovering right around 0 because this is the point in time that we're comparing the rest of these trends to. So when we look over here, this is less than that average of what it was in this time. And when we look on this side of that section, it's greater than that average. Question 5, the gray shaded areas are called error bars. They indicate the range of uncertainty that scientists have about the data on the graph. Why do we think the error bars are smaller in the late 1900s and 2000s than they are for the 1800s and early 1900s? So we see again that it's smaller here than it is here. And if we kind of compare what was going on in the world, now our technology is a lot better than it was back then. Our record keeping is, we have computing and we can share data more readily. Background here, we are uncertain just because we didn't have as much data collecting technologies and ways to record and track all these trends as we do now. So that's why we're going to see that shaded area bigger as we go back in time, but we're getting more precise with our measurements more recently. Question 6 asks, why is the black line so much more variable than the red line? What's the difference between the data they show? So the answer to that question can be found in our introductory paragraph over here. We see that the black points and the black line connecting them is showing us the average annual temperature, so just the data for those 12 months. The red line is showing us the 5-year average over the course of 5 years. So when we're looking at data over the course of long term, we're going to see it changing much more slowly. If we were to look at temperature data over the course of 1 year, there's a number of different factors that could cause the temperature to change just over that 1 year. There could have been a volcanic explosion. There could have been El Nino or a different type of weather factor happening that might have an effect on the global climate or the global temperatures. But the red line is showing us more climate. That's the long-term weather, and those changes are going to happen much more slowly. Let's take a look at the next section, 4. So this next section, we're going to be predicting the future. So how can we take those trends and those patterns that we see right now and make predictions about what's going to happen later on? In this graph, we see the 5-year running average from 1880 to 2010, which is the red line that we saw from the last slide. And here we have 3 predictions. So it's clear that the past temperature data has a trend. Does the past trend help us predict the future? Let's take a look at some of the questions we'll need to answer with this one. What is the overall temperature trend between 1880 and 2010? Well, if we see the anomaly is lower in these years and then we see it steadily increasing, it does go up and down, but the trend over the long term is that it's warming. What was the temperature change between 1920 and 2000? So in 1920, we saw a temperature anomaly of about negative 0.2 degrees Celsius. And in 2000, it gets up to, looks like just over 0.4 degrees Celsius. So we would find the difference. We would do 0.4 minus negative 0.2, and that would give us a change, an increase of 0.6 degrees Celsius. Let's see how we did with those two. Excellent, excellent. All right, number 9. The 3 lines marked A, B, and C on the graph are possibilities for what can happen in the future. Which line best shows what you think will happen to the temperature in the future? So based on our data where we see this steadily increasing temperature anomaly, it seems as though it's going to steadily increase, which is why I would go with A. If we were to look at some of the steps that we can take to not have that, some people predict that if we try to cut our carbon emissions, then we can start to see these temperature anomalies decreasing, or maybe not increase as much as they are. But it seems to be, not only is that the temperature going to be increasing, but it's going to be increasing the amount that it's increasing. Meaning by the year 2100, it's possible that the temperature could be increasing by 1.4 degrees each year. So let's continue. Question 9 says the 3 lines marked A, B, and C on the graph are possibilities for what could happen in the future from 2010 to 2100. Which line best shows what you think will happen? Well, if we were to look at the trend that we see from the data that we already have, we can see that not only is the temperature anomaly increasing, but it's increasing the amount that it's increasing, which is why it seems that line A would be a safe prediction based on the data that we already see. So explaining your answer, I would say looking at the data, it seems as though that the temperature anomaly has increased on average for every 5-year span. Number 11, how certain are you about your claim based on your explanation? And explain what influenced your certainty rating. Well, the more evidence that we can gather and the more data that we can gather, the more we can be certain about our predictions. So this is just one piece of data that we have. We would have to take a look at other pieces of data in order to paint a better picture and make a better prediction about what's going to be happening with Earth's climate. Let's take a look at the next section.